Good morning, students. So let us continue our AC circuits EE302C. In previous classes, we have seen simple electrical circuits. In that circuits, terminology regarding to circuits, we have seen what do you mean by the node, what do you mean by the mesh, loop, passive elements, active elements, passive circuit and active circuit. And also we have seen how the simple problems, network problems can be solved with the help of Ohm's law. The Ohm's law limited to linear circuits as well as simple circuits, we can use it. It's a perfect. Once our network intensity increases, the division of current takes place. At that condition, it is a tedious to solve the problems with the help of Ohm's law. This can be avoided by our scientist Kirchhoffs found two laws. One is Kirchhoff current law and Kirchhoff voltage laws. In last class, definition, that is a statement, simple examples and few problems we have done. What do you mean by Kirchhoff current laws? Kirchhoff current law states that sum of the currents entering into a node is equal to sum of the current leaving from that node, or we can algebraic sum of current entering into a node is equal to 0. The currents which comes towards node we taken as a positive values. The currents which leaves from that node is taken as a minus value. Based on this, we have performed few network problems. Now in this class, we are going to learn remaining portion. Now, what are the objects today? On completion of this topic, you will be able to know, solve the problems using Kirchhoff laws, apply KCL and KVL problems. Now at the same time, yesterday itself we have seen voltage law also. In a closed loop, algebraic sum of voltage sources is equal to drops in a closed circuit. What are the sources is equal to drops across the loads. Based on this one, we have seen how to indicate whether it's a positive or negative while writing the simple equations. And in that, we have observed that once the current is flowing through the resistor and assumed loop also direction is similar, both are same directions, then we are going to take it, that is a negative value, drop should be negative value. Once the current flowing through the resistor or element direction and assumed direction, loop direction, is opposite direction. We have taken that as a positive. If both are same direction, we have taken negative, that drop value, and if the directions are reverse, opposite direction, then we taken as a positive value while writing our equations. At the same time, in voltage sources also, from negative to positive rise in voltage, then we are taken as a positive. Once from positive to negative direction, the drop in voltage we taken as a negative sign in case of voltage sources. Based on this one, last class we have performed a few examples for a given simple circuit. With example of in a closed loop is just closed loop and 2 voltage sources and 3 resistive elements, a simple circuit we analyzed with our family. A closed circuit we assumed as our family, and 2 voltage sources E1 and V1 and V2 is assumed as a father income and mother income, and R1, R2, R3 we assumed as your brother, your sister, yourself. Once the current is passing through these resistance elements, there is a drop occurred at R1 and R2 and R3. That means you are going to consume whatever the amount earned by your parents for purpose of livelihood as well as for your studies. At the same time, we have assumed that at starting day of a month, whatever the salary comes, that is a total evaporated, volatile, that amount at the last day of the month. That means total income comes to our house equal to total amount incurred at the end of that day. What is the saving? Saving here we are assumed as a 0, no storage. In case of KCL also, in case of KVL also. In KCL also, sum of the current entering the node, sum of the monies coming from the different sources into our packet. Money packet is equal to same amount dispersed to the different people. At one stage, what is the amount? The amount in my packet is 0. Sum of the amount coming is equal to the sum of the amount going. Just like you are assuming that in case of a bank employee, in case of they take any type of the bank, suppose for example you take the SBI bank, where at the 10 o'clock at the starting of the bank, the cashier, you can see the one clerk, cashier, he has a large amount of the amount beside him, some lakhs of rupees, and that amount will distributed at the evening, at the closing of the timings. Actually, the amount is not his own. Whatever the amount is given by the bank manager, that is distributed to the different people and collected from the different people at the end of the bank time. So he has to submit a remaining total amount to the bank manager. At that condition, the amount in his control is 0 at the end of the day. Similarly, in KCL and KVL also, the KCL, the sum of the current at the node at any instant equal to 0, because sum of the current entering that node equal to the sum of the current leaving from that node only. And in KVL, the sum of the voltage sources is equal to the sum of the drops in a closed mesh equal to 0. These are we calculated with the help of the simple problems. Now we are going to these simple problems we are going to apply for the basic concept is the same, but our networks are complex circuits. Now go on increasing length of the circuit, number of elements increases, and it is a TDS, but the same formula you have to apply it and do the remaining problems. Let us do one simple 2 problems in this class for your clarity. The remaining problems you have to do it because you should get the good experience by doing these problems. You can enjoy the problems by learning, by remembering what we have discussed. It's a sign whether you are taking the negative value or positive value, and worthless sources and direction, assumed direction or reverse direction, whatever you are, what we have learned the basics, you apply the complex circuits, you are going to get the perfect answer. Now let us see. Now problems. One problem you can take. Here one problem is given. Calculate the current in every branch of the network given below. So one circuit is given. Just like you can remember, this is the Wheatstone bridge. Wheatstone bridge we have discussed in physics. It has 4 arms, A, B, C, D, and connected the AB is one branch, BC is the another branch, and CD is the another branch, and AD is another branch, and AC is the another branch, and BD also branch. How many branches? 1, 2, 3, 4, 5, 6 branches. So here branch current we already know. What do you mean the branch? We know the branch is nothing but in between the 2 nodes. Here A is the one node, B is the another node, C is the another node, D is the another node, and we taken the E is a source. Let us assume that is also one term. Now in branch AB we connected E1 is the one source, one cell connected, and one resistance also we connected. One source active element, one passive element connected in between the AB branch. Now BC branch we connected another one resistance and voltage source E2 is connected. Okay. Now CD we connected 1 ohm resistor, only passive element, and AD also we connected the 1 ohm 1 resistor. Just you listen the procedure. The value 1 ohm, 2 ohm, 3 ohm, whatever the ohms is given, but we require some procedure is required. Now in this case AC we connected the one voltage source, 10 volts voltage source, and connected the 1 ohm, it may be internal resistance, connected across the AC terminals. Now 10 volts is connected across the AC terminal, and it has 4 branches, AB, BC, CD and AD. At the same time another branch also connected, BC also. So in case of Wheatstone bridge we connected the BC as a one galvanometer. Now let us calculate what is going to asking calculate the current in every branch. That means what is the current flowing in branch AB, in branch BC, in branch DC, in branch AD and branch BD. So I require the total current flowing through each and every element. Okay, so we can do it, no problem. Now you can see here. So this is as per our basic knowledge, we are going to identify this, we converted as per our requirement. What you have seen here, from 10 volt source plus minus. So the current is flowing from the source, from the positive terminal. We assumed as a X plus Y, that is some current, unknown current. So sum of the current is X plus Y. The current is flowing through the 1 ohm resistor and reached at a node. At that node, X amount of the current is flowing in branch AB, and remaining Y amount of the current is flowing in branch AD. You can see here. Okay, so whatever the current is coming here splitted. some of the current is flowing in this direction, some of the current flowing in this direction. You can see it. Now after that, here you can see it at the time of the B. So here coming the current, what is the current? Here current is the X amount of the current is coming here from the source. Now we are assumed here is Z amount of the current is flowing in the branch BD. That means total, you apply the KCL here also. Sum of the current at the node is equal to X current. Sum of the leaving current from that node is equal to Z plus this current here, this current. How to know this current? So total input, that is called X. What is the output? Minus Z. Remaining current will flows in this branch, BC branch. That we are assumed as a X minus Z. You can see here also. Okay, then the current is coming here. And at the same time, Z amount of current coming from the B to D, and here, so D is a node. Once again, you assume it. The current which is entering here, sum of the current entering here is equal to the sum of the current leaving from the branch. That means from here we are going to get the Y current, here from Z current. So what is the current here flowing? That is a Y plus Z is the current. Sum of the current Y plus Z equal to sum of the leaving current Y plus Z equal to 0. We are applied KCL. Now it's coming here. What is the current? Y plus Z. What is the current here? So here current is coming. What is the current? That is a X minus Z current is coming, and what is the current here? X minus, okay, leave it. Now here, what is the current here coming? The current is coming X minus Z. Some of the current is coming here. This is coming. This, what is this one? Plus X plus Z. Two currents. Here is current. What is the current now? Now leaving current. Sum of the current is a sum is equal leaving current. So now we can see plus Z minus, sorry, something wrong here, Y plus Z here. This is cancel Y plus Z. Now plus Z minus Z cancel. We are going to get the X plus Y is the current. So same current is represented. That means we know that from basic BE class, whatever the current leaving from the positive terminal, same amount of the current has to enter into the negative terminal. If something is changed, value changes. For example, here the current is coming from the leaving from the positive terminal is the 10.38 amperes, and coming current is equal, for example, 10 amperes only. That means 0.38 amperes is a missed here. That means you done some mistake in the network. Always remember the students, how much current is leaving from the positive terminal, that current should be entered in the negative terminal. Then your calculations might be in sound methods, in correct way. Otherwise, you done some mistake in calculations or your assumption is correct. You check it. Now, so here what we have seen, whatever the current X plus Y, the current X plus Y current is leaving, same X plus Y current is coming into the source, 10 volt source. Then our assumptions are somewhat better. Now this is the, we are applied the KCL. Now apply the KVL now. Now KVL, we require the loop or mesh or closed house. Now here how many loops we can consider? We can consider the 3 loops. What are the loop? This is a loop from, you can see this is a loop 1, from this one, loop 1, and from this one, this is another loop 2, and we can consider this is we are going to consider loop 3, and sometimes we can take this from this one, this was the loop 4. That means we can write 4 loops. So but I required only unknowns are X, Y, Z. So I required only 3 equations for 3 unknowns. We can solve it. If required, I can write in the 4 equations also. Okay. So, what are the equations you can going to write it? Now, you can write the equations. What are the equations? You are going to write it. So, already you know this basics. Now, first equation for a closed loop, loop 1, L1, you can write it, L1 that is equal to A, this is the B, next D, next A. So, A, B, D, A is a first loop, this is a loop 1. Next L2 that is equal to BC, B, C, next CD, D, next B. So, that is the second loop. This is the second loop. Assumed direction. Assume the loop directions. Arbitrarily you can assume it. And another L3. L3 is equal to from A, from this one, next B node, next C node, next D node, sorry, you can write it, that is also D, next A. So, that covered this total node. And L4, loop 4, we can write it. Another is equal, loop 4 is equal A, B, C, and we can write it E, here is the E. Next is coming to the once again A. So, that means from this source to this one, we are going to get the loop 4. Now, L5, another loop I can write it from same E, A, D, C and this one. So, that is equal to, you can write it A, D from this one, C, E, A. So, here I can write the 4 loops. 4 loops I can write. So, I am going to get the 5 equations. I am going to 5 loops. Each loop create the 1 equation, and I am going to get the 5 equations. This from 5 equations, and I am going to find that whatever I required. But here in this case I assumed that only X and Y and Z. So, 3 are the unknown currents. So, I require only 3 equations enough. You take the any 3 equations, you are going to calculate, but the equation which is we are going to write it, it should be the mixed of X, Y and Y, Z and Z and X. That term should be within the equation. Such a way you choose the loops. Okay. So, this is a basic thing, and now based on this one, let us do this one. This is a procedure. First, what are the circuits? You assume it and consider the loops. Now, at the same time, based on the voltage sources, you assume that so plus minus of each element, and after that apply the or basis KCL and KVL. Then you simplify the equations, you are going to get the unknown values. Same problem we can do in a good manner, you can say it. Now, this is a circuit, and now this current is the X current is flowing from the A, and same X plus Y which is coming from this one is once again I am explaining the animation. Now, X current is flowing in branch AB, and Y current is flowing from A to D in the branch, and at the B, X is coming and Z is leaving from that B node, and at the same time the Z current which is passing through the 1 ohm and meet at D, here D node. So, you can see what is the D? This is a D node. Here going to this current is entering, this current entering, here is current is the leaving. Then apply the KCL. Y plus Z, which is going in branch DC. From the B and C, whatever the input current, X current is minus Z current in the BD branch. We are going to get this current. At C junction, you can observe that this current entering, this current entering, this current is leaving. And this current is equal to how much? What is the current? X minus Z. This current is equal to Y plus Z. And combine this one, we are going to get this one X plus Y. Current is coming out from the C network and entered the same battery, which is leaving the how much current is X plus Y. Same current is X plus Y. Okay, so these are simple methods. Now this is a X minus Z, this is a Y plus Z, and this is a X plus Y. So we assumed these values. Arbitrarily we assumed this currents. Now the loop 1 is equal to A, B, D, A loop taken, and loop B is equal to B, C, D, A loop 2, and loop 3 we taken as a from A, B, C, E and A. We taken the loop 3 for our calculations. We require the X, Y, Z currents in corresponding branches. Now let the current direction be as shown in the below. So, apply the KVL for loop, that is first loop we take it A, B, D, A. That means where is the loop? A, B, D, A. This loop, first loop we are assuming. Now what are the values? First from A to B. So A to B there is a two, one is the active element and there is a passive element. The current is coming this direction, A to B direction. Now the voltage is coming minus 2 plus raised voltage. We take the plus E1. Next after that here what will happen? So we are going to, what is the loop? We are assuming the loop this direction, assumption this is this direction. Okay, now what is happening? This current direction and this current direction are both are same direction. You take the negative drop. Now in this case this current direction, this direction is the same direction. You take the negative value here. At this condition the current is coming here, loop current is this opposite direction, take the positive value. Okay, once again you remember that. So here what we have seen, the current which is flowing through the element direction and assumed direction, loop direction are the both are same similar directions, then we have to take that value is a negative value. If the either of the loop current or the element current is opposite directions, both are in reverse direction, we take the drop as a positive value. Same we are going to apply it here. Now apply the closed loop. Now what is happened? Here we take the first loop and apply it. So apply the KVL for the closed BDAB, and so the three loops are we going to apply. Now solution, first loop, so same. So what happened? So minus 2 plus 5 into minus, because the current is the which is current is flowing, it is one direction, loop direction is the same direction. So minus, what is the value of resistance? R into current. I into R now. Now the resistance value is 1 ohm. 1 into what is the current flowing through the resistor? X ohm, X amperes. We take in the X. Okay, minus bracket 1 into current value, I into R. So 1 into X. Next, come into the B to D branch. Now the current in the resistance, the loop current also same direction, we have to take the minus value. Now what is the resistance value? 1 into what is the current? Z current. Now from D to A, then you are going to take the 1 resistance 1 into Y direction. So equal. So I am going to write it, you can see it. This direction current, what is happened here? That is equal A plus minus 2 plus, where the raising the voltage source. So we taken as a positive value. That is what is the value? The E1. E1 is equal to what is the value? 5 volts. Okay. Next, so this direction and the loop direction is this same direction. So both are minus I into R. What is the I? I is equal to X current. What is the R? R is equal to 1 ohm. So into 1 ohm. Okay. Now come to this circuit B to D. So here B to D, only one passive element. The current direction, loop direction same. So we take the minus I into R. What is the current? I is equal current, that is equal Z current into what is the resistance? 1 ohm. Okay. Now B to A. So B to A. So here the current direction is coming this direction. Loop direction is this direction. So opposite direction. We take the plus. What is the resistance? Resistance is equal to 1 into what is the current? The current in the circuit is equal to Y. Then comes to the A and starting point equal to 0. Same equation you can see here. Okay. So plus 5 minus X into I, that is the X is equal I into R. I is equal X amperes and R is equal 1 ohm. We take in the bracket minus. Next from B to D. So here what is the current? I into R. I is equal Z amperes, R is equal 1 ohm. Next D to A, the current direction reverses. Then we are going to resistance is I into R. What is the I? I is equal to Y. What is the R? 1 ohm. Here is equal to closed open. It is a closed end. Then equal to 0. Same equation we got it in this case. Okay. Now after getting this one without any confusion, so you are ready to do the remaining simplification. Just simplify it. Then we are going to get the 5 minus X minus Z plus Y. You write it X plus Y plus Z is equal to some constant value for the equation purpose. X plus Y plus Z, one equation term. Simple. Substituting this value, we are going to get minus X plus Y minus Z plus 5 is equal to 0. This is a first equation, you remember. For the first loop we are going to this equation. Now further you write the second loop. What is the second loop? B, C, D, B. That means this equation we are going to write it. Then we are going to get the another equation. Apply the KVL for closed path of BC, DA. Now write the equation. What is the value? So from this equation. Here is how many elements? 2 elements. So current which is entering here. So we take in the loop is this direction. Okay. So this direction and this both are same directions. What is the current? So that is equal to here current is equal to X minus Z minus current because the direction same there into R. What is the R? R is equal to 1 ohm. So both are same direction. This direction same. Now voltage source minus to plus, simply raised voltage plus. What is the E2? E2 is equal, what is the value? 5 volts. Now this branch is circuit branch terms over. Next C to D, this direction. Here the current direction is this direction, but we loop direction is the opposite direction. Take is the positive values. Now plus, you keep it. Then what is the current? Current in this called Y plus Z current. This is the current in the branch. What is the resistance? Into 1 ohm. Now we came here. Now we are going to this direction. Now what is happening? So here also the current is coming this direction, loop direction is going opposite direction. Then take the positive value. Then what is the positive value now? What is the current? Simple, current is equal Z. What is the resistance? Into 1. Anything? Nothing. B is reached. So starting B, ending B equal to 0. Okay. So here taken from the B to C minus I into R plus voltage source plus drop in C D branch plus and D B branch terms we written. Now simplify these equations. We are going to get the second equation. Okay. So same thing I have written here. Okay. Now by simplifying this equation we are going to get it. So minus x plus 2 plus 5 plus z plus. So we are going to this one. So simple equation minus x plus y plus 3z plus 5 is equal to second equation. From this first equation, this is the second equation. Okay, by simplification, just write the equation carefully, then simplify it, write it x plus y plus z plus some term, constant value, some is equal, constant is equal to, some constant is equal 0. This is the equation. So the first equation, the second equation we got it. But unknowns are, we require the x, y, z. Minimum, I require the 3 equations. I can write it. How many equations? I can write the 5 loops, 5 equations I can write it. But I require the 3 is enough. For your practice purpose, you write the 5 loop equations. From 5 loop equations, you are going to find it, the x, y, z currents. Okay. Now for the simplification, I have written. So I require the only 3 equations. Now I got it. I have got it. How many? 2 equations. I require one more equation as required. Now write the another equation. So what is that one? So apply the another here. So what is this value? Another loop. A, B, C, A. That means A, B and B, C and C, E. C is this is E. From at is going to A. So we take in the house. So from AB branch, write the terms, BC, write the terms, and CE, write the terms, and E to A, write the terms. Okay. So what are the values you are going to get? Now simply write it. So here from A to B, similarly we written the this we take in this direction. Okay, this direction. Now this direction and this are the same. So similarly we written as a what is the current? Current is equal to x, but in the same direction take the minus into what is the resistance? So a source now. Okay, sorry. First you take in the A to B. First is the source. Now source is equal to raised voltage. You take the plus 5 volts. Okay. Next after resistance you take the minus. What is the current? Current is equal to x. What is the value? Is the resistance is equal to 1. Okay. Now B to C branch. So B to C branch we taken as a current direction this direction. So here the current, this both currents are equal. That's the same direction. Then we take the minus value simply. What is the current? X minus Z. What is the resistance? 1. Next voltage source minus to plus, raised plus. What is the value? 5 volts. Now write the C to E. There is no value. Now here direction. So what is minus to plus? Raised voltage plus. What is the 10 volts? Okay. Now coming to here. So this direction, the current in the same direction. Take the minus. What is the value? What is the current? X plus Y into what is the resistance? Into 1 ohm. Coming to here. A we reach the same is equal to 0. Similarly, is first 5 is the raised voltage minus to plus, raised 5 plus 5. Next, and resistance drop here. So what is the current? X into 1, because same direction we take the minus value. Next, in this case, and same direction minus what is the current? X minus Z into resistance 1. Now minus to plus, raised. What is the value? 5. Next, in this case, current is coming here. So minus to plus, raised 10 volts. Next here same direction. So what is the current? X plus Y. What is the resistance? 1 ohm equal to 0. This is a equation we have written in a closed loop of A, B, C, E, A. Same equation you can hear. And simplify this equation. Then we are going to get, so third equation. Simplifying this one, we are going to get the one equation, that is a minus x minus 3y minus z plus 10 is equal to 0. Now we got it. First equation, second equation and third equation. From that we are going to find simple mathematical simplification. We are going to x value, y value, z values. That is the required current. Now, so by solving the first and two, you take the two equations. What are the first equation? So, what is the first equation? So, we taken the first equation previously. What is that one? This first equation is this one. Okay. So, minus x plus y minus z plus 5. That is equation. Okay. For that purpose, just now. So, as we know that, what is the first equation from the loop? So, we taken the first loop, we taken that is called A, B, D, A equation. We got it, first one. So, from this loop, we are going to get one equation. First equation, what is the first equation? That equation is equal to x minus y plus z is equal to 5. That is the first equation from the first loop. In second loop, we got it. What is the equation? That is called x minus y minus 3z is equal to 5. This is the second equation from this one. And third equation from this one, we are going to this equation. So, third loop, we are going to the x, we got it, x plus 3y plus z equal to 10. This is the third equation. This is the equation. So, here from equation, first equation we got it, x minus y plus z is equal to 5, and second equation x minus y minus 3z is equal to 5, and third equation x plus 3y plus z is equal to 10. 3 are equations we got from the three closed loops, and simplify it. From first and second equation, we are going to get this equation, and what is the value? So, we are going to get that z value. So, from the equations 1 and 2, we are going to get the z value. What is the value? This equation. So taking the here minus, plus, and here is a plus taken. Next, you are going to take the minus. So, plus minus get cancelled, plus get cancelled, and minus plus cancel. So, what is the value? Plus 4z is equal to, you are going to 4z is equal to 0, z is equal to 0. So, we got it, z is equal to 0. Okay. So, I think you are the very familiar in the mathematical calculation than me. Simple equations, just to solve it, simplification by changing the terms. Then what is the value got it? Z is equal to 0. That means the current which is flowing through the B and D is equal to 0. That means B potential and D potential are equal. That means current is not flowing between the two nodes, means the current, the two nodes are at same potential. So, no current is flowing through the BD. Now, so we can apply the Wheatstone bench principle. Now, the galvanometer is the zero condition in this case. No current means no deflection. No deflection means no current. So, the B and D are similar. Then that means here this branch and this branch is connected simply parallel, and this branch and this branch is connected simply parallel. So, this is this and this parallel, simplify the series, and this is the simplify the series. We are going to the one series. So, we can apply the once again our Ohm's law. Okay. So, by doing the so many problems, we are going to get the these all ideas. Now, do the next equation. You write it for another z. We know out of 3 unknowns, we got the 1. Remaining x and y, we are going to apply it. So, here do the remaining 2 equations simplification. Now, in this equation, by substituting the value of z in the equation 1 and 2, so we are going to get the third equation. Okay. So, 1 and 2, what we are got it? So, we got it that one, and x minus y is equal to 5. That is equal, from the equations we are going to get the fourth equation. Now, x minus y is equal, we are going to get these equations. Now, and fourth and fifth equation, that is the x minus y is equal to 5, x plus 3y is equal to 10. Now, both are simplified. You take the subtract minus minus, you are going to x is you are going to get 0, then we are going to the minus 4y is equal to, we are going to get that is equal minus 5, minus minus get cancelled, and we are going to 5 by 4 is the current is the y. So you see it, that is equal nearly 1.525 amperes, and we got it the y value. We know the z value, we know the y value. Now simplify these two values, substitute the equation 1 or 2 or 3 or anything, we are going to get the x value. Now substitute this value in the 4 or you are going to 5, you get the value. Substitute the value in the equation 4, then what is the value? That is equal to x minus 1.25 is equal to 5, that is it is going to plus adding, then we are going to the 6.25 amperes. Now from this one what we get? We got it. So current flowing this x value is equal 6.25 amperes flowing through this branch, and from this y branch that is going the current 1.25 amperes going, and current flowing the z branch is 0. Now you remember that. What is the current flowing this one? 6.25. Now in this case x minus z, so x is equal 6.25 amperes, z is equal 0, same current is flowing, that means this current and this current, same current is flowing through the branch, and the same current is flowing this branch. That means whatever the current flowing in this one ohm, same current is flowing here. Now the same here current is coming here. What is the total current? X plus y. X plus what is the 1.25 plus 6.25, that is called 1.5. So 7.50 current is leaving from the source. 7.50 amperes is leaving from that source at the node A as per KCL, divided into 6.23 amperes in the branch A and C, and 1.25 amperes branch A and C through the D branch, D node. So now everywhere we are going to, so what is the current now? That is 7.56 amperes. So we got the all values here. So that is equal to x is equal to 2.5 amperes, y is equal to 1.25 amperes, z is equal to 0. Now knowing this one, so we can, what they asked, current, find the current all branches A, B, this all written simply. Okay, so this is the solution, we got it. Okay, so dear students, it is not difficult, but it was a lengthy problem. If you know the basics, you can easily do it. Okay, so this is one problem. Now, so shall we do another problem? Okay, do the another problem. To solve the bridge given figure from the current through the 4 ohm resistor. Here is one circuit is given. Here what is asking, what is the current flowing through the center? Previously Z current is flowing here. Now what is the current flowing? Z is equal 0 in previous problem. Now in this case the 2 ohms and 3 ohms and 2 ohms 1 ohm is a different. Also previous case all resistance 1 ohms. Now here the change the values. At the source also 6 volts. So 6 volts battery is connected to the bridge. Then you take the A, B, C, D as the nodes, and E is asking what is the current flowing from B to D. This branch current is asking. 4 ohm resistor, what is the current? Then you know the simple apply the equation. Write the 3 equations. Okay. Now how to write, you know. Now apply the KVL to mesh. What is the circuit? A, B, D, A. Similar previous one. So we are going to get that. What is the current here? So same current we are going to apply here. Okay. And what is that one? From the AB. So we are going to get, so AB, the current direction, loop direction same. So what is the current? X current. So minus X. What is the current resistance? I into R, 2 into 2. Now B to D, both are same, minus, what is the I? Z. What is the resistance? Into 4. Now D to A, so now current direction, loop direction, and current through the resistor is the opposite, we take the positive. Then what is the current in this case? Y. What is the resistance? 1. And reach the A is equal 0. So you can write it minus 2x minus 4z plus y equal to 0. Same equation we are going to get it. Okay, similarly you can write it and take the another loop. Take the another loop. Write the x term, y term, z term, similar to the previous one. Now take the another loop and B, C, D, A. So in this case you take the B, C, D, A, this branch. Okay. So what is the write the equations? Now B to C, here what is happening? We take in the direction, this loop direction, this direction. Now the current entering here, this current is entering. So both are same direction. So what is the current? Now current is equal to x minus z current, but in same direction, minus of this current into what is the resistance? What is the resistance? 3 ohms. Okay. Now this direction. Now what is the current here? That current is equal to, so the opposite direction. This is going this direction, this is the, so plus, what is the current? Current is equal to y plus z. What is the resistance? 2 ohms into 2 ohms. Now D to B. Now current direction reverse, you take the simply positive value. What is the current? Z. What is the resistance? What is the resistance? 4 ohms equal to 0. So this is the equation. Okay. So minus x minus z, because both current direction and loop direction is the same, and I into R. I is equal to x minus z. This is the x minus z and the resistance 3 ohms plus I is equal to y plus z into resistance is equal to 2 ohms, and here current is equal to z into 4 ohms, then equal to 0. Then write it the x term, y terms, x plus y plus z term is equal to constant value. So we are going to get that equation. So we are going to get this equation, second equation. Now we take in this loop, and you take the another loop. Okay, similar to the previous one. Now apply the A, B, C, F. You can take here A, B, this one, this one, this one, this one. Okay. So what is the equation? Same previously cases. What the current now? Same loop. So that is current is equal to minus x into 2 resistance I into R plus here the current direction, and this loop is same direction, you take the minus value. What is the current? Current is equal to x plus z, x minus z, here the current, this current, and what is the resistance? 3 ohms. Okay. Now this to this one, no, E to F, so C to F, no current, no drops. Next F to E, F to this current is coming here. What is the current? That is called, so this current and this current is same direction, minus you take it. What is the current? X plus y into what is the resistance? Into 2. Okay. Now minus 2 plus raised plus, what is the voltage? 6 volts. Now comes to the 0 position, equal to 0, equal to 0 value. So this is the equation we written from this to this terms, and this to this terms, and this to this no terms, and here we take in the this term and we take in the last term equal to 0. Now simplify this equation. then we are going to get the x plus y plus z is equal to sum that is equal to third in the terms of this one. 3 equations. So you can write it. This is a third equation. Okay. From this equation, we are going to similar to apply the 1 and 2. We are going to the some value, and 2 and 3 we are going to same value, and the 4 and 5 you are going to x term, y term, z term. This simple equations. By multiply the equation 1 and 2, simplify it, and you are going to get the value from the equation 1 and 2. So we are going to get subtracting. So we are going to get what is the value? So we are going to get that. So x minus z terms, another equation, that is the fourth equation, and write it the second and third equation. We are going to get the another equation that is equal in terms of and x and z, and this fourth and fifth we are going to get the equation. So that is the fifth equation. So from the equation we are going to get the values of here z value. We got it. What is the z value? Z value is equal to 3/91 amperes. This is a milliamperes. That is called. So what we are assumed the current B to D current we taken it has a minus value. That means the current is which is not flowing from the B to D. Now D to B you have to assume it. Previously we assumed that B to D. So we got it minus value. What we are assumed previously for simple calculation arbitrarily is wrong. The current direction is from D to B. Simply change the direction. We got it. This is no problem. Okay. So, but what you are assumed, you have to follow the same consistency throughout the problem. Okay. Now we got the Z value. So Z value is equal 3/91. That is a very milliamperes current flowing from the D to B. Now substitute the Z in the equation of fifth. So x we are going to get it, x value, and so we got it. Okay, substitute the z value in the equation. We can the fifth equation. What is the fifth equation? 5x. You can take it. So if z value you substitute here, we are going to the x value. Once x got it, you substitute the equation in the third equation. Third equation you go to y value. So we are going to z value. From this one we are going to the x value, and from that one value y value. So we are going to x, y, z, all currents we know. But actually he asked how much current is through the 6 ohms. Now the 6 ohms resistance current is equal. This is the answer. Enough. Z enough. Okay. For the clarity purpose I am going to substitute know the x value, z value, x value, y also. Now in this problem he asked only z value. Z value is the 3/91 amperes, enough. But you continue the problem, find it what is the x value, what is the y value. So from that one, so we can know what is the current through the each element in the circuit. So we may get some good experience. Okay, these are the simple problems. Similarly, you have to complete these problems. Okay, in your textbook there is a number of problems n number of problems is given, but you have to do the minimum 10 to 15 problems. So you can get the good idea on this KCL and KVL. Okay, simple applications. Now, so let us summarize what we have seen in this class. In this period we have discussed the algebraic sum of products of currents and resistances plus EMF is equal to 0, that is a KVL, and IR plus EMF is equal to 0, and KVL is applicable only closed path and meshes, and KCL is the sum of the current entering at the node equal to the sum of the current leaving the node. We can go into node analysis purpose, we can use the KCL, and mesh analysis purpose we are going to use the KVL. Okay. So the current direction in the resistor and the loop current both are in the same direction. The voltage drop is taken as a negative, assigned with a negative value, and vice versa. The current direction of the resistor and loop current both are in opposite. The voltage drop is assigned as a positive value. Okay. So at the same time, by applying the basic concepts, and we are going to do the unknown currents in a given networks. Students, please practice the remaining all problems as per your syllabus. Better to solve this type of the problems in BL Tereja value 1. Okay, thank you for listening my class.